Okay, so I'll quickly go through chapter 3, 4, 5 and give a rough overview. You can continue doing what you are, or you can just stop and watch for a few minutes. I'm also recording this video right now on the screen for other students. So let's see what is a list, and as we are using Colab, we have defined one list over here, courses equal to square bracket. So first thing that I understand is to use list, we have to use square bracket first of all. And if you do print courses, we get, of course, the list of courses that we have typed over here. And if you do type courses, we get list. It says class is a list. So courses is a variable of a data type, which is list. And in terms of our concepts of classes and objects, list is a class and courses is an object. So technically, in other words, courses is an object of list class, which is also a data type. Alright, then accessing it fairly easy. So courses 0 is like the 0th element, just like string. Second is the third element, which is BSc in our list. 0 is to 2 is first 2. 1 is to 5 is first 4. Minus 1 is from the last. So the last element was MSc perhaps, right? So yes, so let's just print courses again. Yes, so the last one is MSc, so last item is minus 1. Minus 2 is the second last. So when you have a long list, let's say thousands of items, then you can't give like 2 is to 998 or whatever. You want to say everything except last 2. So that time you can use this. Minus 3 is to minus 1. Again you can you can think it out. It's minus third and minus second element. So minus third is the third element from last, which is this MA, and then the second element was MCOM. So till that, and minus 1 is excluded. So the last item is excluded. So MSc is excluded, and then minus 3 onwards everything. So give me last 3. So then again, every class has its own functions. So list has its own function. Like in string, we saw upper, lower, title, count, replace, etc. If we give like help list, this was like before ChatGPT or before AI days. You used to you have to go through the documentation, and for that you are writing help help bracket list. It tells you everything that is there to know about list. So we can see that append is one function which is defined. As the name says, it appends objects to the end of the list. Copy is one that it does the shallow copy. Now what is a shallow copy? What is a deep copy? Ask AI, and probably you can share that as well. Then let's say pop removes and returns item at an index. So you have to pass an index. By default, wherever there is self, it means that you don't need to pass anything. Self is like it is a Python's way of telling itself that whatever is written before copy, like a.copy, so a is acting as a self. So you don't have to send copy bracket a, rather you just say a.copy. But after self, if there is an index or something else, that is a keyword that it expects, keyword argument that it expects. Okay, alright, so then list append. So if you want to see what does append do, you can do list.append. Alright, so courses.append. So we are appending B at the end. We are inserting ME at the third location. So first we had BA, BCom, BSc. Then we inserted ME in between at the third index, which is the fourth location, ME. And then the rest of the things are happening as they are. Then we appended something through a variable. So we defined this B farm as a C. And then we have a new list, and we are appending list. So this is important to note here that we have this list till MSc, and then we are appending a new list. So for this courses, the last element is this list. So it treats it as one element because it's a one element. And then if you are getting the last element is after this comma. So we get the entire list as it was. And if we use extend, then we get then it is separated from the list and then added. So for example, we had this list and then we are saying that extend it with new, and the new was our 11th and 12th, and here you can see it's comma separated by 11th and 12th separately. So if you want to kind of merge two lists, we use extend. Pop by default removes the last entry, so we used pop and then 12th has gone, so it is removed and we got 11th. If we say remove and if we say BA, then it is removing BA from it. In the pop, if we don't give location, it automatically does the last one. Maybe if we give index, we do get that at that point whatever the entity is that might be gone. So let me check it once. So let's say we do pop 0 and courses.pop 0 and let's see if BA is gone. So we have this, okay, so it is giving me the only that point. So let's say if I do courses 1, it is only listing it. So I think it has removed it and given it. So let's say if you do courses now, okay, so let's try a new example. Let me do test equal to A, B, C, D, and let's do test.pop and let's do second and print test. Okay, so it removed the item at the second one. Second location was C, so it removed that. And if I don't do that, let me comment this and do print test again. Alright, so we got this and print test dot pop. Then by default it should give it should remove the last element. So it is printing the element that it was removed. We should do something like this, print test. Yes. So now it is clear that when we are doing test.pop print, we are getting the element that was removed. But when we are printing test again, we get the answer. Okay, alright. Remove A and then courses.sort. So here we are trying to sort it. I have to run courses again. So let's say okay, we don't have okay, I have to print from start actually. So courses is this one, and let's come over here and courses.sort. So what is sort doing? Let's check. This should give error, read below, you can comment it. Okay, you'll get error because you followed the code so far. The error says that it is not supported between instances list and str. It's because the sort cannot understand how to deal with that another list inside, right? So we had that list which I have not printed right now. So if we have this list, then it will give error. But basically it just sorts it out. Let's try it separately. We have these fruits, right? Let's try doing sort over here. So we have mango, apple, orange, and if we are doing sort, then we got it in the alphabetical order: apple, kiwi, mango. And if you do reverse, it is sorting it in the reverse order. So sort and reverse are useful for items where we have serial IDs 1, 2, 3, 4 or alphabetical orders. Then what is there? So let's say sort works on the list with only numbers as well. So we have incremented and decremented order. One thing we can note about list is that the order is preserved. So this order is always the same the way it is defined. So if the first element is Russia, it will always be the Russia unless we actually change it. We can use length. Length is the count of elements in the list. So here we have 7 elements, so it is printing 7. And same way length we had in the string as well. So we are just checking. We can get the maximum number as well in the list, maximum, minimum, sum. Okay, so I have not printed called this, so print. Then max countries, min countries. So when I am doing max countries, it returns one with the highest alphabet. So the longest word and the shortest word. Iterating a list. Now this is where your for loop comes in picture. So unlike C++ where we use curly brackets, in Python we don't have curly brackets. We don't use curly. We have curly brackets in some other cases, but not for the for loop. It is the loop is signified by these spaces. Now by default, Colab gives the 2 spaces, but the VS Code normally uses 4 spaces in the block. So you can think of wherever there are spaces like 2 or 4, it's a different block which is running in the for or any other loop. So here we are saying for item in countries. So country has a list. For item in countries print item, so we got separate item now. It could be anything. For I can do for X in countries print X. So the first one doesn't matter. It automatically understands that we are referring to the individual element inside this variable. And here we are just demonstrating who is inside, who is outside. So here you can see that this print was outside and this print was inside, and we have separated it through this separator. So here we got only once, and here we got multiple times, because the print statement and this print are on the same line, which means they are in the same for block. Here we are just adding one more thing. We are saying that print length of item. So for each item, give me the length of that item as well, which is item is a string, so it is giving me the string. So the size of Russia is 6. Here we are printing 3 things, upper and size. Here we are trying to use f string. So in the f string we saw we use placeholder of curly brackets, and inside that we have the variable name. So item dot upper, and then length dot item. Sorry, length item. Enumerate is a special function. What it does is, instead of this for item in countries, we are saying enumerate countries. That's the only difference. If we do enumerate, so it's a verb coming from the numerate, and numer means number. So you are saying that give me numbered, enumerate it, numberize it. So you numberize the list. So your countries is a list, numberize it. So it is numberizing it as 0, 1, 2. So it always gives you the ID of it, the index of it. Common nomenclature in standard programming is also underscore. So instead of ID, they also write underscore, comma that. Anything works though. So enumerate, and then we are printing index and item. Then here, what are we doing? We are appending. Okay, so we are doing a cube. So range 5 is a list of first 5 elements, 1, 2, 3, 4, 5. So you can explore what range 5 gives. In short, it returns numbers up to 5. So 0, 1, 2, 3, 4. And what we are saying is, inside cubes, append the cube of it. This is the cube. Raised 2. It's as good as like this symbol. So you give me a cube of it and you append to yourself. And if you want to check it in every step of the way, then we can do print cubes inside it. And then here we can say print final list. Okay. And then let's run it. So here you can see that first it was 0. Here also let's have one print. So print by default, before going to the for loop, what it is doing. So before going to the for loop, it was blank. Then it went to this loop, and then it got I equal to 0. So cubes dot append 0. So cubes they appended 0, and then print cubes, which is 0. Then again process happened, and then it appended 1. 1 cube is 1. Then it went to 2. 2 cube is 8. Print cubes append. So then appended 8, and so on and on. And then at the 5th one it ended. And then the final list we printed. To deconstruct what is exactly happening in the above code, you can use print like this. Alright, so we just tried doing that. Yeah. Then nested list. So a list can be, so one thing we are checking is list is on, in the sense you can have any random number of data types in list. So here we have two lists. You can also have numbers, integers, and whatnot. So let's say you can have 1, 3, 0, true. All of that is also, it does work. So list doesn't care that the elements are of what data types. You can have a list of different data types. And you can have list of list, list of list of list of list. You can have nested lists as many as possible. And in the matrices, we'll see this more often. Okay, so we have got that. Then fruits 0, fruits 1, we got two lists. And then we are printing what is the data type of first element, what is the data type of second element. Now we also did this 1, 3.4 and two, last one. So let's try doing data type of them as well. So fruits 2, 3, 4 and type 2, 3, 4. So we got one as an integer class, 3.4 was float and true was boolean. And then this is how, so this will be useful in NumPy particularly. So list of list, right? So 0th item, and inside that give me 0th item. So that was mango. And in the first list, so second list technically, give me first element, which is sitafal, this. So that was list, and let's quickly go through tuple as well. So tuple is similar to list, but there is only one difference. There is one primary difference, that the items inside tuple cannot be changed. So here if I come, I can see that, so I have opened the fourth element now, fourth collab sheet now. Tuples we are defining by the round bracket. And if we say type, we get type tuple. And for accessing it's the same way. So most of the things in tuple are similar to list. Most of the elements are also similar to list. We can count a certain element, we can print the index, but you cannot add or change element in tuple once it is created. So that's why there is no add or insert method to the tuple. So one clear, let's say, where would tuple be highly used? Any thoughts? Just take a moment and think in what cases tuple would be extremely important. Somewhere where backend is not able to change itself. Somewhere where passwords are, because it's not a list in a technical sense. So while password need not be changed, we use encryption for password but not tuples, but it's a good example. Where else do we shall the tuple be used in the programming field, in the backend field particularly? So it is used in returning data from database. Whenever you are using database queries, especially SQL Alchemy and other packages, when database data comes to backend from database, the backend should not be able to change it right away. So it always returns data in tuple, and then you extract that and then handle it separately. And then if you want to do a new addition to the database, you use the insert query to the database. But the returning of it, if I say that select star from XYZ, then the answer of that query will come in tuple. So that's the most effective and most unique use case of tuple. And that's where most of it is used always. So list is more commonly used in general. Tuple has a very limited use case. Alright, so similar to list, we can iterate through list items, tuple items, we can have enumerate. All other things are mostly the same. Very less amount of times you will use tuple in general, so it's just good to know for now. and then whenever we are using SQL Alchemy, we'll see the application of it. Um, all right, so I'll just move on. So connect two tuples. Can we do that? Yes, we can connect two tuples. More than two tuples can also be added in the same way. So this is new one, new two, and then we got new tuples. Now we can see that this is this is as good as extension of a list. So it just increased items in that tuple. We can delete the tuple using this command del. Okay, what is happening? I check whether an element is in the tuple. Okay, so we have defined a tuple of fruits, and here we are checking mango in fruit. So this is a shortcut in Python to use, if mango is in fruits, print true. Instead of that, you can directly use something like this. Max and min is also works on tuple. All right, so this is fairly self-explanatory. Let's check dictionary. Dictionary is also highly used. So list and dictionary are the most important data type, derived data types in Python. Dictionary all the way more, because dictionary is used in many senses. Like all JSON files are also dictionaries. And before starting this, you may have seen JSON schema example. Let's just see what is a JSON. So you might have seen things like this, where there is a curly bracket, and then comma, and then colon. All API definitions, API get values, etc. are used in JSON. In fact, if you are also in video production using VO, you might have seen that VO model, which is Gemini's model, supports JSON prompts. So the AI was actually checking JSON prompts for generating videos, and here you can see one example. So let's just see if he has given any example. If I go to comment VO3 JSON. So even AI understands a lot of things in JSON format, and JSON format is nothing but a dictionary format of Python. Let me just see if there is, okay, he has not given it, but okay, so technically the VO model supports JSON format really well. So if you want to have good videos, you give prompts to AI through JSON, and JSON schema is like this. And that is what dictionary is exactly in Python. So we are using curly bracket to define a dictionary. Inside a dictionary, there is new concept called key value pair. Itself is called key value pair. So this is a pair. Name is the key, value is the Tesla. Founder is key, and then the value is Elon Musk. So this is a key value pair. So it's in a way, it's a combination of key value pairs of a comma separated elements, let's say. So this is the simplest, simplistic example. Let's just run it, and it is being printed as it is. Too many sessions. Okay, I have to kill some sessions. 1 second. So let's just stop this. Okay, so it got printed. So we are saying print company, and then here we are trying to check the data type as usual. So it says class is dictionary. And then now we want to access the element. We cannot access it through the index. We have to access it through the key value pairs. So company name, and then inside company we have three keys: name, founder, established. So the first one is Tesla. Just the length of company. So length of what is the length of this dictionary means how many keys are there. So there are three keys. So the length is 3. And now we are changing. Let's say we want to change the value of this key name. Then we are just changing it like this. We are just assigning company name and assigning a new value to the company name, and then it got saved. Same way we are changing location. So location is not there, so we are directly adding company location. And now if we add the company, we get like the fourth thing in the dictionary. So we modified the dictionary. Now what are the functions? Okay, so through dictionary we can find out many functions. Let's skip that for now. We can also use .get. So .get and then you have to pass the key. So one way is it is as good as saying print company square bracket name. Both of them are same. Okay. And then if I do print company dot company and then name where E does not exist, and if I run this, we get an error. So it says that key error. So key is wrong. But here it did not give us, okay, one thing. Here we did not get an error for get. Here also we are using deliberately a wrong key. And here also we are using the wrong key. But here we don't get error. Here we got the error. So in this syntax, Python affirms that this already exists. It assumes that, and then it tries to find it out. And then it finds out that, oh, this does not exist. And then here it gives error. Here this is more of a softer method. It says that, okay, get me this. If it is not there, then just don't give me anything. So it gives you none. And if you don't want none, you can also write something like this, xyz. If I do comma separate xyz, so here we got xyz. So what this means, you try to get this key. If you don't get this key, directly print whatever I am writing over here. So that's get. So get is more generic. It has less error chances, and this is more error prone, but it's also more straightforward. Okay, keys and values. So we can print separately keys and values. So the keys of company are name, founder, established, and later on we added location. The values of that dictionary were these. And new key, new value, we added new key, new value. Alright, here we are printing a new dictionary. And then we are popping the class. And then here we can see that class has gone from the list. Sorry, from the dictionary. Then we can also use delete. So we use del. And if we type student class, then that is gone. Clear, everything is gone, everything is destroyed. Looping, okay, so loop is interesting, loop is important. So we have this dictionary, name Apple, it was founded in 1975, founder Steve Jobs and Steve Wozniak. For item in new, the format is same, print item. So here we got only name, year and founder, okay, we did not get the values. So if we want to print the values as well, we write it like this. So item and new inside that item. So for item in new, it gives us the key. Then for each key, give me the value of it. So it is as good as saying that this is a key. So it's for key in new, print key and new hyphen key. Sorry, new square bracket key. So I have to run this first, and then I will run this. Okay. And another way, so for example, we know that in dictionary we have key value pair, so it has two things automatically. So we can directly say like this: if it's a dictionary, we can use this function called items, and here we have checked items, right? Did we check items? No. Okay. So we'll try printing that as well. So if I just do here, if I do print new dot items, so we get these new items. So name Apple, years 1975. So this is, it's a kind of, it is printing a tuple, list of tuple in a way. So here what we are saying is the first one is item, the second one is val in these new items, and then print them separately. So it is directly accessing two elements than one. Here we are accessing only one element for key in new. But then we know that new is a dictionary. Dictionary has key and value. So we can have two things over here. This is as good as saying, if instead of this, if we write for a comma b in new dot items, print a comma b, that also works. That also works equally. Okay, and then if you want to sort only through keys, search only through keys, we can do that. If you want to do only from items values, we can also do that. Okay, sorted, you can sort it alphabetically. You can have the list sorted, list of the keys. Okay, let's go to another important part, which is nested dictionary. This is where JSON comes more and more in picture. So we have this list, we have this dictionary, and for the founder's key, the value is again a dictionary. So if we are printing this, we got key value, key value, key value. But the value of this founders, is another dictionary. Just 1 second. Okay, so the value is the dictionary, and here we are saying print company founders. We got another dictionary, and then company founders inside that first one. So fairly straightforward to see how we can access elements. And then for item and value in company.items, so we are printing separately. So the first name, so this name and Apple we printed separately. Then year and 1975, and then the founders, and value for that is this entirely. So that value is printed as it is. And then that value, we are again cross checking that it's of a class dictionary. So we can here, we can just do one more thing, print type val. So Tesla is string, Elon Musk is string, established 2003 is integer, location US is this. Okay. Okay, I have not run this probably. Let me see. Right, so name is Apple and with the string. Then second was 1975, which is integer, and the third value was this, which is actually a dictionary. So yes, I think that's pretty much about dictionary. Spend more time on dictionary because there are two things, key and value. It's more useful, and the next session will have the API handling, API management, which is mostly JSON and dictionaries. So get your concepts right for this. And the last one, sets, we have deliberately left blank. You have to use ChatGPT to understand, or anything else. I had created this before GPT, so I haven't mentioned anything in this sheet about that. But you can also go to this site and check what is sets about. And then after that you can go on with the 7th and 8th and other things. So I'll again stop here. You finish these three. I'll try to make a video of the remaining chapters separately, which I'll add in our LMS. I think it's already 12 o'clock, so by 1 o'clock you should be able to finish at least till 6, and 7 to 12 you can do by night and try to finish everything by night. All right, I'll stop here for any questions, and I'll give, like, you guys are free to start coding and doing everything again.